All right, let's look at a static equilibrium problem. Let's assume that we have some guys on those scaffoldings that are hung over the thing so they can clean windows or paint or whatever they need to do. Let's assume that this board across is 4 meters. The scaffolding itself has a mass of let's say 20 kilograms. They have some supply tools. Each one of these supply tools, like we'll call this tool 1, and that one's tool 2, they each weigh 2 kilograms. And they're a quarter meter away from the edge on each side. And then we'll assume that this person is 1.5 meters in, and worker 1, this is worker 1, they have a mass, or person 1 has a mass of, let's say, 60 kilograms, and this person is 1 meter away from the edge, and person 2 has a mass of 70 kilograms. And what we could ask is, what's the normal force on the different cables, on the 2 cables? So what's the tension in this cable, tension 1, what's tension 2? So to solve this problem, we're going to need to look at equilibrium. So the first part is we sum the forces in the y, and we say that that has to be 0. So we look at all of the forces. The first force is tension 1, and that's up. The next one is tool 1. We'll call this equipment 1, and this is equipment 2. And this is minus E1. We have the weight of the scaffolding itself minus weight of the scaffolding minus the weight of the person 1 minus weight of person 1 minus weight of person 2 minus equipment 2, the weight of equipment 2, plus tension 2. So what do we see is that tension, I'll write this over here, we see that tension 1 plus tension 2 has to equal all these weights. It has to equal equipment 1 plus equipment 2 plus the weight of person 1 plus the weight of person 2 plus the weight of the scaffolding. So that's what we know in the y. Now, what do we need to know to figure out tension 1 and tension 2? What we're going to have to do is we're going to have to sum our torques. You should either pick this end, or the middle. But if you pick the middle, then you would have to do some kind of, you'd have to substitute in without a number, solve this one to get a number, and then you could back solve that to get the other number. So a faster way to find either tension 1 or tension 2 is to pick one of the ends as the rotational point, and then you'll solve for the other tension and plug that in. So let's just assume that our pivot point is here along the line of tension 1, and we'll go from there. So we sum our torques about this point, and that has to equal 0. So about this point, equipment 1 generates a clockwise torque. So it's going to be minus the 0.25, because that's how far away it is, not 0.25, just 2.5, times the 2 kilograms times 9.8. The next thing is the person, and they are 1.5 away. They have a mass of 60 kilograms, and it's 9.8. The next one is the weight of the board, and that's at 2 meters, and it had a mass of 20 kilograms, and that's 9.8. Now the next person, we know they're 1 meter from this end, which means they're 3 meters from the other end. And they too are causing a clockwise rotation. So this is equal to, and then we have another line over here, minus, in this case, the 3 meters times 70 times 9.8. Then we have this weight. It too is causing clockwise rotation. And this is 3.75 away, because if it's 0.25 from this end, it's 3.75 from the other end. And this one weighs, equipment 2 also weighs 2 kilograms. That 2 goes there, and that's 9.8. And finally, at the very other end, tension 2 causes a counterclockwise rotation, so it's 4 meters away, and it's tension 2. Tension 2, when we add these all up, tension 2 has to equal is 853 newtons. So now that we know tension 2, we can come back up here and solve for tension 1, because we see that tension 1 is weight 1, which is equipment 1, which is 2 kilograms times 9.8, 19.6. Equipment 2 is also 19.6. The person 1 is 60 times 9.8. Person 2 is 70 times 9.8. And the weight of the board is 20 times 9.8. And from all of that, we subtract the tension in the cable, 853. So we have equipment, person, weight of the board. So tension 1, we can solve for that. Tension 1 is 656, and tension 2 is 853, which makes sense because the heavier person is actually sitting closer to this cable, and the lighter person is actually a little bit further away from their side. So we expect a little bit more tension up on that side than on that side. But this is the idea of static equilibrium. We have to look at summing the forces in the Y and looking at the sum of the torques. Now in this, and we have to have those equal to 0. If they weren't 0, then the system would be rotating or moving. And in this one, we had a whole bunch of different things that our 2 upwards cables had to support.